Right, commonly in both the Algebra 1.2 and in the Tables and Graphs exams, we'll be dealing with a lot of quadratic equations. They take this general form here, ax squared plus bx plus c, and that is definitely something good to remember, especially because we need to remember that there is an a term in front of the x squared. There'll be more on that later. In a factorized form, generally we'll see two pairs of brackets. And quadratic equations describe the shape of a parabola. So before we get into factorizing two brackets, I'm actually going to start by expanding them. Here is a factorized quadratic equation. It's in two brackets, and we use the FOIL method to expand it. So first of all, x times x is x squared. X times 2 is plus 2x. 5 times x for the inside pair, which is 5x, and finally the last is 5 times 2. And then we just group our like terms, and we get our final expanded version of a quadratic equation. Now the question is, how did I get this 10? Where did it come from? If we work backwards here, we'll see this 10 came from that last pairing where I multiplied my 5 and my 2. So I'm going to be trying to find two numbers that will multiply to get to 10. And the other question then is, how did I get to the 7? I actually added my two numbers, the 2 and the 5, together to get to 7. So what I'm doing when I factorize a quadratic equation is I'm actually looking for two numbers that will be factors of 10, they multiply to get to 10, and here they add to positive 7. So let's go through that now. So remember, first of all, that the general form for a quadratic equation is ax squared plus bx plus c, and in this case, there's no a term in front of the x squared, which means it's actually an invisible 1 there. We just have 1x squared. So we're going to use the grouping method to do this. Now, I really like this method because it will work for any kind of quadratic, and not only that, it checks your work as you're going through it. You actually know if your answer is correct before you get to the end. So, step 1, we multiply the coefficient of x squared, the a term, by our constant c. Okay, so in this case, when there's nothing in front of the x squared, it's a 1. So we just have a 1 times 10. So we know we're working with 10 as it is. You'll see later on that when we have a different coefficient in front of the x squared, that will actually be multiplying out and looking for factors of other numbers. Okay, the next thing we need to do is we need to find the factors of this positive 10 that add to positive 7. So we just go through listing them. We have 1 times 10, 2 times 5, and actually I can stop there because I know a 2 plus a 5 when I add them together equals 7. So those are going to be my two factors. So now I rewrite my equation as the two factors split out as the coefficients of bx. So I'm taking my two factors, I've taken my 7x and I've split it into the plus 2x and the plus 5x. Okay, you'll see when I add them together I still have 7x, but I'm just splitting it out to those factors. Now I'm going to split the equation in half. I'm going to take this first pairing and the second pairing and factorize them individually separately. So I look at my first one and I see I can factor out an x from this side and I can factor out an x from this side. There's an x to the power of 1 in both of these. So once I factor them out, I put an x on the outside and I'm left with x plus 2. Now looking at this one, I have 5 is my highest common factor on both sides, but no x in both sides. So I'm actually going to factor out that 5. I'm going to have a 5 on the outside and then x plus 2 on the inside. So that's this side factorized. And notice here, this is the key thing, and this is why I like this so much. We have an x plus 2 in both sets of brackets. We have the same thing in both sides, which means we have done it correctly. We already know that we've done this correctly. if we have the same thing on both sides, our answer is going to be right. So finally, what we need to do is take the two outside of the bracket terms, this x and this 5, and we're going to turn them into a new bracketed pairing. So they're going to be an x plus 5 in one brackets. The other bracketed pair that's the same on both sides, we just take one of them and we put that in as the second set of brackets. So we take our x and our positive 5, they go into one set of brackets, and then that bracketed term that we have in both sides becomes the other one, that x plus 2. And that is our factorized quadratic equation. So let's just do a few examples. So I have an x squared plus 8x plus 15. Now we have a 1 in front of this x squared here, so when I multiply that, I'm going to be looking for the factors of 15. So I'm going to write a little note for 15 there. Okay, so what multiplies to get to 15? We have 1 and 15, 2 and nothing, we have 3 and 5, and I think we're going to be able to stop there. So 3 times 5 is 15, and 3 plus 5 is 8. So those are the two terms that we're going to use. So step 2, I'm going to take this plus 8x and I'm going to split it. So x squared plus 3x plus 5x plus 15. Now, I'll show you in a minute the other way around, but it actually doesn't generally matter which way round I write my factors in, the plus 3x here or and the plus 5x here, or the other way around. Although sometimes once you're used to doing this, you'll notice that you'll find maybe a certain number here will be easier to use with this final term here, or this number here might be easy to use with your x squared. You'll just get used to seeing that, and so you can swap them around however you want because we are adding them both here. Okay, now that I have two terms here, I'm going to split it down the middle here. I'm going to factorize these, so I have an x on both sides, so I'm going to factor out the x, and I'm left with an x plus 3. And what I'm hoping here, and I can already see it's going to happen, is that I'm going to end up with an x plus 3 on this side. So on this side, I can factor out this 5. It's the highest common factor. So the 5 goes on the outside, and I'm left with an x plus 3, because 3 times 5 is 15. And I have the same in both sides, so I must have it right. And let's just take our two outside terms, x plus 5. It's a positive 5 that I factored out, so it's a plus 5 in these brackets. And then I take the other bracketed term, x plus 3. And I am confident that is right. I could always double check it by expanding out again, but I'm not going to do it in this instance. I'm pretty confident because I have the same terms in both sides here. Now I'm just going to quickly do it one more time, the exact same one at the top here. I'm just going to swap around the 3 and the 5 just to show you. So I could rewrite it as x squared plus 5x plus 3x plus 15. So I've swapped my two inside terms. Split it. I'm left with x plus 5 on one side, and I'm left with 3x plus 5 on the other side. Okay, because I've got that highest common factor of 3, and if I take my outside terms, I'm left with x plus 3, and my inside terms x plus 5. And notice, as much as that they're the other way round, I've got the exact same thing going on here. Because they're multiplying, it doesn't matter which order I put my brackets in. If I'm multiplying a 3 times 5 or a 5 times 3, I'm going to get that same answer. So it doesn't generally matter which order you put these terms in. Alright, let's look at the second one here. We have x squared plus 3x minus 18. I'm going to do 1 times 18. Now the key thing though with this 18 is it's a negative 18. So I'm going to be looking for the factors of negative 18. So that could be a 1 and a negative 18. It could also be a negative 1 and a positive 18. Because we need a negative times a positive to get a negative answer. So I'm actually doubling up all my factor pairs. Once you're used to doing this, you'll actually find that you won't need to be writing out these. You can just be looking at the two numbers and going, okay, if I add this as a negative and this as a positive, what will I get? If I add this as a positive, whatever, what will I get? But let's just do it the long way this one time. So I can do 2 times negative 9, or negative 2 times positive 9. I can do negative 3 times 6, And I can, oh, I'm actually pretty confident with that one there if I add those together. The other one of this pairing would be, of course, 3 and negative 6. But if I add these together, here, negative 3 plus 6 is a positive 3. And here, 3 plus negative 6 is a negative 3. So this here is the pair I want to use. So I take that pair, I split it. So I'm going to do it, I'm going to decide which way around. I'm actually going to put my two negatives together. I think maybe that will be the easiest way to do it. I've got a negative 18, I could put a negative number next to that. So I'm actually going to write it like this: x squared plus 6x minus 3x minus 18. That way I've got my two negatives on one side. Okay, so x plus 6x, I'm going to factorize this as x plus 6. Okay, now here's what's going to go on here when I factor out a negative 3. I'm going to take out a negative 3 here because I should be ending up with a positive 6 here, so a negative 3 on both sides. Now if I divide that out, I'm left with just an x. Now how many negative 3's go into negative 18? Well, a negative divided by a negative is a positive, and it's a positive 6. Okay, so we've got to be very careful with our signs. And these are both the same. I know I've done it right, so let's just rewrite our final answer. We take our front two numbers, and this is a negative 3, so it's x minus 3. And then our bracketed terms, x plus 6, and there is my final answer. Okay, this one looks interesting to me. Let's see what we get here. I'm starting to think, just looking at this, that we have a perfect square going on here. So I'm going to multiply, first of all, my 1 times 4, so I'm looking factors of 4, and I have 1 and 4, and I have 2 and 2. Now, what's interesting here is that I'm actually having to add to a negative 4 this time. So 1 plus 4 doesn't add to negative 4, 2 plus 2 doesn't add to negative 4. However, if I make both of these a negative times a negative makes a positive. So one thing we need to do when we look at our quadratics is, if we have a positive here, do we have a negative here as our b term? Because if that's negative, then we know that our two factors are actually going to be two negatives, because we need to add this negative 2 to another negative 2 to get to negative 4. But I know those are going to be my terms. So let's rewrite it. X squared minus 2x minus 2x plus 4. I'm going to split that down the middle. I have an x minus 2 on this side, and on this side I'm going to factor out a negative 2 on both sides. So when I factor out that negative 2, this cancels out. I'm left with a negative 2 on the outside. I have x, and now how many negative 2's go into 4? Well, two 2's go into 4, and there's one positive, one negative, so my answer is going to be a negative. Okay, I have an x minus 2 on both sides, so I must have done that right. Let's group our terms together. X minus 2, x minus 2. Now both of my bracketed terms are exactly the same. So what we have here is a perfect square, and so ideally you're going to remember that when you have the same thing multiplying itself, we could rewrite that again as simply that one bracketed term squared, okay, because we have a perfect square. So we have x minus 2 squared as our final answer for this one, because these are exactly the same. Alright, hopefully when you see this one, you could recognize that as a difference of squares. So what's going on here is there's no b term, which means when we add our b terms together, our two factors together to get to b, we end up with 0. So if I was to write this out in a longer way, it would be actually x squared plus or minus, it doesn't matter, 0x, and then minus 49. That's actually what's going on here. We need to get to a negative 49, and those numbers need to add to 0. So when we are getting to a negative, it must mean that we have a positive and a negative. So let's just go through our factors. So we have a 1x squared. So I'm going to go 1 times 49, and I'm looking for the factors of negative 49. Now I know already that 49 is a square number. Hopefully we already know what our factor pairs are going to be. But we know we're multiplying to get a negative, so one's going to be a positive, one's going to be a negative when we multiply them. And when we add them together, they need to equal 0, which means they actually need to be the same. And because we have a square number here, we know that that same number times itself, the square root of 49 in other words, is 7. And so we must have a positive 7 and a negative 7. Positive 7 times negative 7 is negative 49. Positive 7 minus 7 is 0. So these are going to be our two terms. And those can go straight into the brackets. We can skip everything else. We know that it's going to be x plus 7, x minus 7.